morning, my dear students. Welcome to this chemistry digital class. As you know that we are doing biomolecule chapter, in which the first member of biomolecule is carbohydrate. And if I will tell about carbohydrate, according to your book also, carbohydrates are primarily produced by plants and form a very large group of natural occurring organic compounds. Some of the common examples of carbohydrates are cane sugar. If I will write glucose, starch, potato, in starch, potato, rice, these are coming in starch, cellulose, okay, then fructose. Fructose is also like glucose, only with different ring, okay, then sucrose. These are some of the example of carbohydrate. So generally the formula, if I will say formula, the formula of carbohydrate is CxH2O(Y). It means that if C is 6, so dear student, H2O will be also 6. The formula will be C6H, 6 2s are 12 and O6. Okay, so this is the formula of glucose. And if I will tell about the definitions, the carbohydrates may be defined as optically active. Carbohydrate may defined as, so according to this definition, carbohydrate may be defined as optically active. पॉलीहाइड्रोक्सी ऑप्टिकली एक्टिव का मतलब होता है कि अगर उस पर कोई लाइट पड़े तो दैट विल शो डिफरेंट स्ट्रक्चर, दैट विल चेंज द स्ट्रक्चर. सो ऑप्टिकली एक्टिव, ओके. पॉलीहाइड्रोक्सी मीन द ग्रुप ऑफ OH, एल्डिहाइड CHO और कीटोन C+O. एल्डिहाइड इज इन द फॉर्म ऑफ ग्लूकोज and ketone is in the form of fructose, or the compound which produce such unit on hydrolysis. Okay, so there are basically different type of carbohydrate. So basically, dear students, if we will talk about the classification, in classification, first the carbohydrate classified on the basis of monosaccharide, oligosaccharide, polysaccharide. We can classify carbohydrate on the basis of number of sugar molecule, okay. If there is a one sugar, then it is called monosaccharide. Then when there is between 2 to 10, more than 2 and less than 10, then oligosaccharide, and more than 10 large compound of saccharides are polysaccharides, okay. So now meaning of saccharides I am using, so meaning of saccharide is sugar, okay. And why sugar? Because it is sweet in taste, that's why these are called sugar also. Most of the common sugar are sucrose, and in milk that is lactose is present. So let's discuss the basic classification of carbohydrate. So basically monosaccharide, oligosaccharide, polysaccharide are the three basic classification of carbohydrate. Now mono means single, saccharide means sugar. So these two, monosaccharide and oligosaccharide, are sweet in taste type of carbohydrate, and oligosaccharide is 2 to more glucose, 2 to 10 glucose are there, more than 1 saccharides, whereas polysaccharide are non-sugar because it is non-sweet in taste, and it form largely in plants and animal thing, okay. So if we will talk about monosaccharide, already we did glucose. In monosaccharide, aldose and ketose are two groups on the basis of function group, like those saccharides in which aldehyde group is there. Aldehyde group is present in C1, that is called aldose. Glucose is the one example, whereas there are on the basis of number of carbon, there are some more compound of aldose are also there. So let me tell you, according to this book, you can see as it is given in this book. If there are 3 carbon, then it is triose, and if it is the group of aldehyde, then it is aldotriose. Group of ketone, then ketotriose. If 4 carbon is there, then tetrose. Similar way, aldotetrose, ketotetrose. If 5 is there, then pentose, aldopentose, ketopentose. 6 is there, hexose, aldohexose, ketohexose. This is the example of glucose and fructose. 7 is there, heptose, aldoheptose and ketoheptose. Now my dear student, I think you came to know that what is the meaning of aldose and ketose. When aldehyde group is there, that is aldose. and when ketone group is there, functional group is there, then ketose. So fructose is the example of ketose, in which C1 have ketone group. In glucose there is C1 have aldose group. That you understood in the structure also. So glucose formula is C6H12O6, fructose formula is also C6H12O6, whereas glucose is aldehyde functional group, fructose have ketone functional group. Similar way, we have done monosaccharide. Now if today I'm going to tell you about the oligosaccharide. In oligosaccharide, the most common oligosaccharide is disaccharide, in which di mean 2. It means that somewhere 2 saccharides are there. So when it break down, it hydrolyze, or if I say when disaccharide on hydrolyzes with dilute acid or enzyme, it gives 2 molecules of monosaccharide. These molecules may be either same or different. If it is same, then it is called a similar type of monosaccharide. If it is different, then it is different. So the 2 monosaccharide units are joined together through an oxide linkage, which is formed by the loss of water molecules. Such linkage between the monosaccharide units are called glycosidic linkage. It means that disaccharide, 2 saccharides are linked with each other with the help of one linkage, that is glycosidic linkage. Sucrose and maltose and lactose are the example of disaccharide. Sucrose, maltose, lactose, like glucose, fructose are example of monosaccharide. Similarly, sucrose, maltose and lactose are example of disaccharide. If I will tell little bit detail about sucrose is made up of glucose and fructose. One glucose, one fructose. When it will hydrolyze means when it will break down and water molecule will take out, then it will change into glucose and fructose. So dextro glucose and dextro negative fructose are the basic component of sucrose. In maltose, it is present in milk, sweet in taste. So alpha dextroglucose plus alpha dextroglucose. It means that 2 glucose, when 2 glucose will link with the help of glycosidic linkage, it will form maltose. When 1 glucose, 1 fructose will link, it will form sucrose. When 1 dextrogalactose and 1 dextro beta dextroglucose, galactose and glucose will link with the help of glycosidic linkage, it will form lactose, which is reducing sugar. So it is present, sorry, maltose no, lactose is present in milk. Okay. So all these 3 examples are of disaccharide. Now if I will tell you the structure, so one PDF I will share. With the help of that PDF, dear student, you need to practice the structure of sucrose, maltose and lactose, and you need to compare the structure of sucrose, maltose, lactose with glucose and fructose also. Once if you understood the structure of glucose and fructose, then it is very easy, because in sucrose you have to combine glucose plus fructose, in maltose you will combine 2 glucose, in lactose you will combine galactose and glucose. Okay. Third and most important carbohydrate is polysaccharide. Poly word mean many. Poly mean many here, so many mean more than 10. Large compound of saccharide, these are non-sugar, non-sweets in taste, mostly found in plants and animal. Large compound of monosaccharides are there. Basically starch, cellulose, glycogen are the 3 different type of polysaccharide, in which starch, if I will tell about starch, it is the important storage polysaccharide of plants and the most important dietary source of carbohydrate for human being. High content of starch is found in cereal, roots, tubers, vegetables, etc. It is a polymer of alpha glucose. Polymer of alpha glucose means many alpha glucose will be combined and it will form a long chain. Okay, and it consists of 2 components, amylose and amylopectin. It is made up of amylose and amylopectin, which will be linked with the help of alpha glycosidic linkage. Okay, whereas cellulose, it is the most organic substance in plant kingdom, which is constituent cell wall of plant cell, and the linkage is beta glycosidic linkage. Here it is starch is alpha glycosidic linkage, cellulose will be linked with the beta glycosidic linkage. In which way? Third type of polysaccharide is glycogen, in which it will store, its storage is basically it is storage material in animal, and it found in the animal starch. It is also called animal starch, and it is found in liver, brain and muscle. Now let's discuss the structure of sucrose, maltose, lactose, starch, cellulose and glycogen. If I will tell about the different structure of different carbohydrates, so monosaccharide, oligosaccharide, polysaccharide, 3 type of carbohydrate. If I will tell monosaccharide, there are 2, glucose and fructose. So if I will tell about their structure, if the structure of So this is already, you know, dear students, the structure of glucose. This is the open structure of glucose according to Fischer projection. If Fischer projection we will say, so this is the open structure. We know very well there are 1, 2, 3, 4, 5, 6 carbon, in which first carbon have aldehyde group. This is aldehyde group. In glucose aldehyde, so in fructose there will be ketone group. Okay, and second, all the hydroxide is toward right hand side. All the hydroxide is right hand side, and all the hydrogen is on left hand side except the third number of carbon. Okay, except third number of carbon. And why it is like this way? These OH can shift toward left and right because most of the monosaccharide are optically active. थोड़ी सी लाइट इन पर पड़े तो ये अपने रोटेट होना शुरू हो जाएंगे, एंड OH कैन बी फ्रॉम राइट टू लेफ्ट हैंड साइड. इफ आई विल टेल द फिशर प्रोजेक्शन, there are two type of projection we got, that is dextro and levo. Now what is dextro and levo, that I already told you. So if we will find the Fischer projection, according to Fischer projection, the alpha glucose and beta glucose. So what is the difference? In alpha glucose, basically dear students, first you will see this OH, carbon number 5 OH. This will start to link with first carbon, which will convert aldehyde into alcohol. This will convert this aldehyde into alcohol, both side aldehyde into alcohol. You can see here now alcohol group is there from aldehyde. This will be there when only this H will link with this carbon. Okay, OH will link with carbon. So dear students, from here now we will see first number carbon. This is first, second, third, fourth, fifth, sixth. Sixth carbon is same. Third, fourth, second carbon is same. Only the change is between fifth carbon and first carbon. In case of first carbon, aldehyde change into OH group. First carbon, aldehyde change into OH group. But the difference is the position. You can see here. This side, OH is toward left side. In this beta, OH is left side. In beta, OH is left side. Again, in beta or levo. In levo, this is also levo. This can be say levo also, levo rotatory. This is dextro rotatory. Okay, levo rotatory, left hand side. Levo rotatory, okay, just pay attention dear students here. In levo rotatory, the OH will be on left hand side. In dextro rotatory, the OH will be on right hand side. Okay, this is because of optical isomerism. So this is also known as, dextro is also called as alpha dextro glucose, and levo is also called as beta dextro beta D glucose. Okay, now the position of this first carbon hydroxide is changed. Here it is left hand side, this side it is right hand side. Okay, rest same, only the thing is there out of third, except third carbon, all the hydroxide is on right hand side. Now in case of this also, in first carbon, the hydroxide is on left hand side in case of beta, and right hand side in case of alpha. Okay, now there is one more projection, that is Horth projection. In Horth projection, the structure of glucose, I'm not going to tell you the trick. Structure of glucose is taken from the same. Okay, now how it is there, you just see. First you will see the link between carbon number 5 and carbon number 1. Between carbon 5 and 1 there is oxygen. So it means that first we will make carbon number 1 and carbon number 5. So there are 6 carbon, in which CH2OH is the 6th carbon. Now give the number 1, 2, 3, 4, 5 and 6. And 6th number carbon, first, second, third, fourth, 5, 6. So if we will make alpha dextrocyclic glucose, then the carbon, whatever is the right hand side. Okay, if we will see now from this dextro glucose or alpha glucose, the alpha glucose cyclic Horth projection, 1, 2, 3, 4, 5, 6 carbon is there, in which the carbon number 5 and carbon number 1 is linked with oxygen. So here also carbon number 1 and carbon number 5 will be linked with this oxygen. Then rest carbon 2, 3, 4, 5 is there. With 5 there is CH2OH. Okay, in the form of branch. if you will see carefully. Now one trick I am going to tell you. Whatever is on right hand side, that we will write down, okay, and whatever is on the left hand side, that we will write up. Again, right hand side, whatever branch is there, that is down. Left hand side, whatever hydrogen and hydroxide is there, that we will write up. So here, follow this. C1. First H is left hand side, that will be up. OH is right hand side, that will be down. Second H will be up, OH down. OH up, H down. H up, OH down. Similarly CH2. Then in second when there is beta, so only the difference is only this OH. It is down in alpha, it is up toward up on, it is down to in the alpha, and it is up to in the beta. Rest is same. Okay, so this is the structure of glucose. Now in the similar way we will make the structure of fructose, and if we will talk about fructose, the formula of fructose is same, C6H12O6, which is of the glucose, but the difference is that in glucose it is aldehyde, it is aldohexose. Glucose, if we will tell glucose is aldohexose, it means that the compound of aldehyde, whereas it is ketohexose. Okay, so it is the group of ketone. So dear students, if I will take your if you will draw your kind attention to just see here, there is a double bond there is a double bond O. This is C double, you can see here, sorry, no problem, it was same here. At number second carbon there is a double bond O. So 6 carbon, 1 2 3 4 5 6 carbon we will make, in which first carbon is CH2OH, alcohol. Last carbon is CH2OH, that is alcohol. Second carbon have ketone group. Third, you know, very left hand side OH. Fourth and fifth have right hand side OH. In the same way, the way we have done in glucose, the fifth carbon and the first carbon will link with the help of oxygen by by hydrolyzing. So here ketone also, when fifth carbon will link with second carbon, here the link will be between C1 and C5, C2 and C5. In glucose the link was between C1 and C5. Okay, so C2 and C5 will connect with the help of O, oxygen. So it means that OH will be, if we will talk about alpha, in alpha dextrofructose, OH will be on right hand side. In beta dextrofructose, this OH will be on left hand side. Okay, you can write this like this way also, you can write like this way also. Okay, this CH2OH you will write this side. So now if you will see, rest is same. If you will see the cyclic structure, so you know very well, between second number of carbon, this is first, this is second, between second number of carbon and fifth number of carbon there is O, oxygen. Between second number of carbon and fifth number of carbon there is O. So first is CH2OH, second is C, and if it is right hand side, so we will write down. If it is left hand side, we will write up. It is down, it is up, it is down, it is yes, this is up because this is this side, and this H is down. So beta dextrofructose, now change is that the position of OH. Here OH is toward this side. If I will make it with the help of some sketch, so you can see this OH is in this OH is on right hand side, or here this OH is on left hand side. Okay, so this is all about fructose. Now dear students, like monosaccharide we have oligosaccharide. If we will talk about the structure of oligosaccharide, the first structure is of sucrose, in which sucrose, when we get hydrolyzed, it is combination of two glucose and fructose. It is combination of sucrose will be combination of one glucose and one fructose. It means that when we will get hydrolyze means इससे पानी निकालेंगे, when it will we will add water in this in the presence of HCl, so then it will give us glucose and fructose. So it is combination of glucose and fructose. First we make glucose structure, just we have studied that carbon number 1 and carbon number 5 will link with oxygen, then 2 3 4 5 and 6 it will be in combination. Then this is the structure of glucose, and this is the structure of fructose, in which the OH, there was OH, you can see here, in glucose there is H. If we will take beta, OH in alpha. If we will talk about alpha carbon will link with beta carbon. So here it is H, here there is OH. So H and OH will link now, and with the help of glycosidic linkage, this is very important, with the help of glycosidic linkage, the two glucose and fructose will link. So two monomer will link with the help of glycose. Similar way, second disaccharide is maltose distribution, where glucose will react with glucose, and a combination of glucose and glucose will give us maltose, okay, in which hydrolysis of maltose yield 2 moles of alpha dextroglucose. It is composed of 2 alpha dextroglucose unit, in which C1 of one glucose unit is linked with C4 of another, okay. So let's practice it with the help of one structure. So first we will make glucose. You know very well, between C1 and C5 there is one oxygen, and now CH2OH, here this side H, here down OH, OH up, H down, H up, OH down, here H, then this will link with O, okay, and H up, then one more glucose we have to make. Six ring glucose is there. So here H, OH, CH2OH, and H, OH, and H, and OH. So both the structure we will make same, but this link is called glycosidic link, glycosidic linkage. This is between 2 alpha dextroglucose and alpha dextroglucose. Clear? So this is a hot structure of. Third, my dear student, is third disaccharide is lactose. Third disaccharide is lactose, where glucose plus galactose, combination of glucose plus galactose, or you can say galactose plus glucose, okay. Here also it is commonly known as milk sugar, and why it is called milk sugar? Because it is found in milk, and it is composed of beta dextrogalactose. So the difference between glucose and galactose is what? There is difference in OH only. So again we will draw in the same way, like this. Here is, you know very well, CH2OH, here H. Now difference is in this OH and H. You can see H in this structure. In glucose, H is up, OH is down. In galactose, OH is up, H is down. At number 1, 2, 3, 4. At number 4 carbon, okay. Then OH up, H down, H up, OH down, and here H. Now see, now the link will be up and down. It is opposite link. Mean if we will make it, it will become down. It will, the structure of this glucose will be make down. So I am making in this way. That is also correct. Okay. So glucose CH2OH, you know very well. H is up now. OH up, H down. H up, OH down. Here H up, OH down. OH down. This is beta position, and this is also called glycosidic linkage. So one common thing, two monomer always in disaccharide, two monomer always link with glycosidic linkage. Here it is between glucose and fructose, here it is between glucose and glucose, here it is between galactose and glucose, okay. This is beta dextrogalactose, whereas it is beta dextroglucose. Clear? So these are the basic component of disaccharide. Now tomorrow I will tell you about starch and cellulose also, or you practice the two component of polysaccharide. That is, if I will say polysaccharide, number 1 is starch, structure of starch. Number 2 is cellulose, structure of cellulose, and there is no structure of glycogen. So dear students, this is all about for you. This is your homework, and rest these things I have told you, okay. So this is all about structure of carbohydrate, and tomorrow in live class I will tell you about the protein. So this is all about from my side. Thank you very much. Hope so you like this video and you understood everything. So thank you. Thanks a lot. Have a nice day.